Hello and welcome, everyone. My name is Dane Menke. I am the Digital Marketing Manager here at REGENESIS and Land Science. Before we get started, I have just a few administrative items to cover. Since we're trying to keep this under an hour, today's presentation will be conducted with the audience audio settings on mute. This will minimize unwanted background noise from the large number of participants joining us today. If the webinar or audio quality degrades, please disconnect and repeat the original login steps to rejoin the webcast. If you have a question, we encourage you to ask it using the question feature located on the webinar panel. We'll collect your questions and do our best to answer them at the end of the presentation. If we don't address your question within the time permitting, we'll make an effort to follow up with you after the webinar. We are recording this webinar, and a link to the recording will be emailed to you once it is available. In order to continue to sponsor events that are of value and worthy of your time, we will be sending out a brief survey following the webinar to get your feedback. Today's presentation will focus on incorporating CSIA in vapor intrusion investigations. And with that, I'd like to introduce our presenters for today. We are pleased to have with us Dora Taggart, President of Microbial Insights. Dora has focused on the optimization and implementation of molecular tools for environmental remediation, microbiologically influenced corrosion, and microbial source tracking. Since joining Microbial Insights in 2001, she has developed and commercialized over 60 different nucleic acid-based analyses. Under her direction, Microbial Insights has become a worldwide provider of molecular tools for leading consulting firms, government agencies, and academia. We're also pleased to have with us today Dr. Sam Rosolina, Director of the Compound Specific Isotope Analysis Laboratory at Microbial Insights. Sam received his BA in chemistry from Berea College in Kentucky and went on to complete a PhD in analytical chemistry at the University of Tennessee in Knoxville. He is constantly working to broaden the scope of remediation analysis through the implementation of cutting-edge methods and instrumentation, and is focused on making these analytical methods more accessible overall. We're also pleased to have with us today Tom Szocinski, Director of Vapor Intrusion at Land Science. Tom is a nationally recognized vapor intrusion expert with over 17 years' experience as an environmental scientist, focusing on vapor intrusion assessment and mitigation, remediation, site assessment, and brownfield site management. He has served on both state and federal regulatory vapor intrusion review boards, assisting with development of vapor intrusion and mitigation guidance, regulations, and exposure criteria. All right, that concludes our introduction. So now I will hand things over to Dora Taggart to get us started.
Thank you very much, Dane. Thank you everyone for joining us today. So as Dane mentioned, we're going to be talking about how we can use a molecular tool called Compound Specific Isotope Analysis and how we can incorporate that tool into our investigations into vapor intrusion to elucidate a lot more data and to be able to make more effective decisions in our site management. So as I get started, just to be sure everyone's familiar with us, Microbial Insights is an environmental laboratory. We've been doing molecular analysis for almost 30 years at this point, and we really value these tools because we think that they add a lot to the site assessment. And Microbial Insights has worked closely with REGENESIS for more than 20 years using these tools. They complement a lot of the REGENESIS products and technologies and can help validate what's happening in the field once we add an amendment, an electron donor or an electron acceptor, or we do some type of process in the field. So I think you're going to see that these tools are very valuable. And even though the focus of the presentation today is on vapor intrusion, there are a lot of ways that our technologies complement each other. And so as we've been doing this analysis over the past 27 years, we've learned a lot of information about samples. And at this point, we have over 30,000 samples in our database that we've done molecular analysis from all 50 states in the US and over 40 countries around the world. So we have a lot of data on the molecular side that we can use to provide context. So Sam's going to show you at the end of the presentation today how not only do you get quality data on your compound specific isotope analysis, but we have a database that can really help you to analyze that data, to put some context to it, to really understand what's happening. And so it's really our goal at Microbial Insights to make sure that our analysis complement what you guys are doing in the field. We really have a passion for this to make sure that we provide quality data that you can use in site assessment. So for 2019, our theme throughout this year has been the ripple effect. And when we were thinking about this, we thought even small actions have a ripple effect that can cause changes on a larger scale. So at Microbial Insights, we're literally looking at things on a molecular level as a piece of the puzzle. Then when we combine multiple lines of evidence, that can lead to more informed decision making, which in turn leads to faster site cleanup. And this in turn leads to protecting our assets and our environmental receptors. This then means better groundwater quality and results in a safer world for our families and for future generations. So as I mentioned, we've been developing these tools over the past 27 years. I've been with Microbial Insights for 18 years, and I've seen the evolution of the tools. We have a lot of different technologies that are available, including quant-array analysis, which is using quantitative PCR to help us understand the biological potential at a site. So we can quantify different organisms or genes that we're interested in to look at degradation processes. We can use tools like stable isotope probing to help us document degradation of compounds like petroleum hydrocarbons to prove that they're biodegrading in the environment. Sam's going to really get into a lot about the compound specific isotope analysis today and how we can use that to document chlorinated solvent degradation, particularly in focus with vapor intrusion. And then we do have some other tools called biotrap samplers that we can use in a variety of ways to test different amendments, and we routinely do this with a lot of the REGENESIS products. So a quick overview on what we're going to do today. We're going to start by giving you an overview of the technique itself. What is compound specific isotope analysis? Then talk to you about how to sample properly, particularly in regards to vapor intrusion. We're going to talk about the value of using multiple lines of evidence to be able to get good whole data to understand everything that's happening at your site and to really put it all into context. And then, as I mentioned, we're going to show you some of the CSIA database and what you can do with that technology that can help you add even more context to your samples and the results. And then Sam's going to walk you through an example study so you can see a true application of this type of data. So when we talk about vapor intrusion, we're looking at any kind of intrusion that's happening in our subsurface. And particularly, we're focusing on volatile organic compounds that come from a subsurface source. So we might have a type of oil spill or a chlorinated solvent spill that has maneuvered that's under housing developments or factories or stores and businesses. And so we'll look at the soil, ambient air, subslab, indoor air samples to kind of help us elucidate and understand what's happening in those conditions. And a lot of times there are indoor sources that we don't think about that can confuse our remediation or redevelopment efforts. So it's really important for us to get a good understanding of what's happening, what's coming from this subsurface intrusion, which part is it coming from, and then what do our other products have that we use maybe internally or as humans that we have that are affecting what we're seeing in our vapor intrusion. So why do we find that this is useful? Well, the reason that compound specific isotope analysis in particular is very useful is because this is a technique that physical processes really have a negligible effect on. So if we look at a ratio or an isotopic signature, which is typically our ratio of 13 carbon to 12 carbon in our contaminant, we can use that as a fingerprint for our indoor air sample. And that fingerprint can give us a lot of information because it can help us to understand the fingerprint of that indoor air sample as a whole. And then we can use it to potentially differentiate between what's coming from the subsurface vapor intrusion and what might be from an indoor source, as I alluded to just a moment ago. So what if we're using different chemicals for cleaners? There's paints that are used in our homes. If we have glue products or different aerosol products, or what if someone's simply smoking in that area? We can introduce different chemical sources that can affect the isotopic signature of our indoor air sample. So it's really important that we can differentiate what's coming from these products and what's truly coming from vapor intrusion from the contaminant. And the good thing with CSIA is once we have this signature, these contaminants are very little effect on the change in their isotopic signature happens from advection or diffusion or dilution type processes. And so we can start to differentiate not only vapor intrusion from other indoor sources, but we can start to understand if our vapor intrusion itself is in fact biodegrading. So the way that we do this is we're going to look at a ratio of stable isotopes. So typically in the environment, the most common one that we look at is the ratio of 13 carbon to 12 carbon. In natural organic compounds or compounds that are synthesized, most of the carbon that we find in nature is a 12 carbon molecule, 99% of what's there. Only 1% is a 13 carbon molecule. And we can do the same thing for hydrogen and for chlorine as well. So we can look at these different stable isotopes within our contaminant, and we know that contaminants will have varying isotopic ratios that are based on how that contaminant itself was mass produced. So the production has a big impact on that, or can have an impact on it. So the best thing is if we can measure that pure contaminant, we can get that isotopic signature and compare it to what we're seeing in our samples themselves. If we cannot get that, what we can do is go to literature and look where the production of different compounds has been measured for that particular contaminant. We can get the range of those values, and then we're going to take the most conservative value and use that as our benchmark, so that if we see something that is more positive, there's more 13 carbon, as we'll talk about in just a moment, in our sample than what we would see in the most conservative production process, then likely we're seeing biodegradation. So we'll have these different isotopic ratios. We'll figure out what the ratio is for our pure contaminant of interest. And then what we'll do is compare it to our sample, because during biodegradation, what we know happens is that the 12 carbon bonds, which are most common, are slightly weaker, and they're going to react more quickly. So you're going to see an accumulation of 13 carbon, so an increase in your 13 to 12 carbon ratio in your sample, and it happens in a very predictable manner when it is biodegradation that's occurring on our samples. So if we know our pure contaminant concentration, we see the concentration of the 13 or the isotopic signature of our 13 carbon to 12 carbon ratio in our sample, then we can start to see, is it biodegradation or is it simply dilution or dispersion that's happening in our sample. So the terminology today, before I turn it over to Sam to give you some more information, is we're going to display data in something called a delta value. So this is the ratio of your 13 carbon to your 12 carbon compared to that of an international standard. And around the world, everyone uses PD belemnite. So that no matter what lab we're using, we're going to be able to get similar isotopic ratio values. So as the bonds break, we see degradation. We're going to see an increase in our delta values from that isotopic fractionation. So for instance, if our compound was typically negative 32.3 delta value, and our sample comes back at a negative 25.1, then that's more than 2 delta positive. So it's more increase in our isotopic fractionation. And that means that we're seeing degradation in that sample likely. So if we do sampling across our site, as Sam's going to talk about, and we do a good job of characterizing our sites, then we can start to put these values into real application to understand what it means. You're also going to hear it called a per mil value, and literally what we're talking about there is it's a 1 to 1,000. So we're looking, because the changes in our isotopes, if you think about 13 carbon versus 12 carbon, the weight of that change is very, very small. So we're talking about fractions of a percentage. So the scientists that originally developed this called it a per mil value so they could multiply by 1,000 so that we get numbers that are a little easier to deal with. So that rather than saying to you, your delta value is 0.0008, I can say it's 0.8. So just to simplify how we talk about these values. So I'm going to turn it over to Sam now and let Sam go through and talk about how you can use some of these dual isotopes together and then go into the database and give you some examples.
Thanks, Dora. I'm excited to talk to you all today because I love CSIA, and this specific webinar harkens back to one of my first webinars that I gave for Microbial Insights many years ago, except now I get to apply our brand new CSIA database, so I'm excited to bring that up today. So as Dora mentioned, we can use CSIA for many purposes. Generally, the most common use for CSIA in the environmental remediation industry is proving without a doubt that a contaminant is degrading, and that's done by watching those delta values change. So as Dora said, we might be able to measure a compound like PCE, and so we're measuring distinct compounds. That's why it's called Compound Specific Isotope Analysis. And so if we're looking for proof of degradation, we're seeing that those delta values will increase either over time or down gradient, and that gives us direct proof that a contaminant is degrading. Now, the use for CSIA when it comes to vapor intrusion is for, most importantly, for distinguishing sources. So as Dora mentioned, there can be many different internal sources that can cause confusion in VOC analysis of specific samples from indoor air. So for example, we might see lots of different chlorinated solvents in different types of adhesives or paints. And again, like Dora mentioned, we might wonder whether we're actually seeing benzene vapor intrusion that is originating from groundwater beneath the building, or is it really just benzene that's originating from the cigarette of the construction worker in the room next door? So that's the kind of question that we want to answer. And in order to do that, we need an isotopic fingerprint. Now we can compare single delta values, and I'll talk about that later, but to get truly the best resolution and the best isotopic fingerprint, what we want to do is compare two different isotopes. So for chlorinated solvents, that would generally be carbon and chlorine. So you can see now on this plot, on this dual isotope plot, that we have carbon 13 on the bottom on the x-axis, and then chlorine on the y-axis. So what we're looking at is those delta values for each of those isotopes. So also, as Dora mentioned, there's kind of a box showing up on this dual isotope plot, and that box represents all of those literature values that was mentioned previously that have been recorded by scientists. And it may seem like a pretty simple box, but that's been a lot of work by a lot of hard working researchers. So what this box tells us is that these are the ranges of isotopes that have been recorded for undegraded PCE samples. So for PCE direct from the factory, undegraded, we would expect it to wind up somewhere within this box. And so this is useful information for us for vapor intrusion, because if we're looking at an internal source, if we're looking at a pure source that's within an adhesive or paint rather than flowing underneath the building, then what we would expect is that that sample would show up within that undegraded contaminant range. And this is useful when we're comparing that to a subsurface source. So if we then compare to a subsurface source and we see that the subsurface source is highly degraded, in other words, enriched in those isotopes, they're higher delta values, then we have direct proof that these two are not related. And so this is the main use for CSIA and vapor intrusion, and it adds a lot of value as an extra line of evidence when we're trying to determine what's actually going on at a site. So what's the process when we're looking at CSIA of vapor intrusion? The first thing that we would start with is standard VOC analysis. And I'll be bringing this up throughout the talk, but we always want to approach this as a multiple lines of evidence approach. So we want to treat CSIA as an added line of evidence and never the single line of evidence. It's always in addition to any other information. So we're going to treat this like a standard site, whether it's a brownfield remediation or if we're looking at possible vapor intrusion issues in commercial buildings or private buildings. And we're going to do VOC analysis of indoor air, ambient air, subslab, soil gas, and then we're going to also look at some of the groundwater samples nearby. And the next thing that we're going to do is we're going to determine the sample volume required for CSIA. I'm not going to talk about that in this talk because it requires a little bit of math and a little bit of added information that we just don't have time for today. But I will be showing you a document that can give you that information, or you can always email me, contact me afterwards, and we can talk about the best way to determine that. But based on those concentrations that you determine from the VOC analysis, we can figure out whether it's best to use a canister, like assume a canister, or sorbent tubes, like thermal desorption tubes. And then from there, we would sample for CSIA analysis. Now, the way that we do CSIA analysis is we're going to compare an indoor fingerprint from an indoor air sample to that of groundwater samples that are just up gradient of the building. So I'll be talking about that as well. So again, for some of the sampling requirements for CSIA, we can either use the TO15 method, so using those canisters, or the TO17. Again, that's based on the concentration of the contaminants that are in the indoor air and also knowing what kind of volume we need for true CSIA representation. And then the next thing that we're going to do, again, is looking at the groundwater samples. Now, the reason we look at groundwater samples rather than soil gas or subslab is mainly because it's easy, it's not as time consuming, and it's less expensive. But also there have been studies that have shown that both subslab and soil gas can give a little bit more of a conflicting data as far as isotopic analysis goes. So groundwater analysis is good for a couple reasons. First of all, it's shown to be the most representative of what ends up in the indoor air if it is vapor intrusion. And then second of all, it's the most conservative option as far as determining whether it is in fact a subsurface place that has initiated the vapor intrusion itself versus an indoor. So when we're looking at groundwater, we want to do a few things. We want to take a sample from a monitoring well that is just up gradient of the building in question. And that gives us possibly slightly less degraded than what we would see in the indoor air. But again, that gives us the most conservative value that we can have. We also want to screen it at the water table because that's also kind of the depth that we're looking at for vapor intrusion as well. So there's a great guidance document on this that was put together by McHugh and Beckley from GSI, as well as University of Oklahoma's Dr. Philp and Dr. Cooter. I highly recommend checking this out. This is a great user's guide that can give you kind of all of the details in the best locations to sample, how to determine what your sampling method is as far as SUMAs versus thermal desorption tubes, and a little bit of added information into how they determined this this research to show us that we can truly differentiate between indoor sources and external subsurface sources. So I mentioned that one of the key things here is knowing what the indoor source range is, or knowing what that manufactured range is. So this kind of magic box that we're applying to our plots. But the question then is, how do you know what that range is, right? If you get the data, how do you know what to compare it to as far as a manufactured range goes? And so that's kind of where we come in. We realized recently that there's a lot of this data that is out there, but a lot of it's also kind of behind paywalls. So in literature, it's in publications. And so what we've done here at Microbial Insights is we've taken all of this data and all of this information, and we've put it all together for you in a single database that can then be applied directly to your analyses. So what that ends up looking like now is that once you do CSIA with us, you automatically have access to our brand new CSIA database and workstation. So you'll have access to all of the values that are specific to your samples in question. So if you had TCE analyzed, for example, you will then have access to the manufactured range for both the Delta 13C, and if you did the chlorine analysis as well, you would have access to the manufactured range for the Delta 37 chlorine. So this is extremely useful because you can now look at each of those individual references that come from the literature themselves. You can use those in your reports and prove that this is in fact based on literature values themselves. But then the best part is within the workstation, once we've analyzed the CSIA and we send you the invitation and you log in, what you see is your data directly on the screen. And you can compare that to the parent compound. In this case, if we're looking at TCE, it applies that manufactured range box for you. So now you have kind of a more visual concept of this comparison, which is extremely important in this case when you're only comparing two data points. So for example, this single square that I'm showing here for TCE is made up of 29 different carbon literature values and 27 different chlorine literature values that you no longer have to go and search out and find yourself. So then you can compare those values and determine what does this most likely look like, an indoor source or a subsurface vapor intrusion source. So we're going to go through a few different scenarios to kind of talk about what this looks like. What does the data tell us, and what do these arrangements look like? So we'll go back a few steps and remind you that if TCE, for example, has degraded, then it's going to be moving in our dual isotope plot. It's going to be moving either up or to the right of our manufactured range box. So that's if it's undergone any kind of degradation, it's going to be moving out. So our ideal situation is that our groundwater sample has undergone degradation, because that gives us the clearest distinction between the groundwater sample and that manufactured range. So in this case, we see that our groundwater is indeed more degraded than our indoor air, and also our indoor air sample shows up to be within that manufactured range. Then we're looking at a clearly, this highlights an indoor source. So again, just to clarify, our indoor air sample is within our manufactured range. It appears to be undegraded, which is what we would expect from an indoor source. And our groundwater that's flowing underneath the building has TCE that is clearly degraded. So because these two fingerprints don't match up, this is just like CSI, we're looking at clearly different distinctions here. Now, if we have both of these degraded and they're very close or similar in isotopic fingerprints, this is a pretty obvious one, but this would show us that the indoor air sample matches the fingerprint of the groundwater that's flowing underneath the building. So this tells us that this is very likely to be a vapor intrusion issue for our TCE. What if both of these fingerprints match, but they're within the manufactured range? Well, kind of a similar thing, right? If they're close enough together, then we can say that the fingerprints match. And just because they're both within that manufactured range doesn't mean that it is not vapor intrusion. So in this case, it looks like our groundwater TCE has not undergone very much degradation. And so because it has not undergone very much degradation, we don't have a clear separation, and it appears to match that of the TCE found in the indoor air sample. So again, kind of some clear definitions here of what does it look like for vapor intrusion versus an indoor source. Now we can get a little more complicated with this. What if our indoor air sample is outside the manufactured range? Immediately what we can say is that if there is an indoor source, it's not the sole contributor. Because if there was only an indoor source, it would be undegraded. It should show up within that manufactured range box. But if their indoor air sample is kind of in between our manufactured range and that groundwater sample, this kind of highlights that this may be a mixed source. Because remember, we're sampling the groundwater from up gradient of the building in question. If that groundwater shows a more degraded TCE than when it reaches the building itself, then it looks to be possibly a mixed source. So in this kind of situation, we would want to go back, do some more sampling, do some more types of analysis to get a clearer picture of what's actually occurring. What about a situation like this, where our groundwater is in fact more degraded than our indoor air? This looks like it could be an indoor source because these values are very close to one another, but it's too close to call. It may also be that the groundwater is separate, but those two values just happen to line up close to each other. So this is another good example of why we would use multiple lines of evidence to corroborate what's actually happening here. CSIA, again, is not a silver bullet, should never be treated as one, but it is extremely useful when used in the context of all other analyses. So now that we've gone through some of those examples of what the data would look like under certain situations, I'm going to run you through an example scenario of a redevelopment of a manufacturing plant. So this is kind of a brownfield remediation site. So a few things to note up front. Is indoor vapor present? Of course it is, otherwise I wouldn't show you this case study. And then the question is, what contaminants and what are their concentrations looking like? Is it an issue in the indoor air? If so, how can we compare that to other sources? We can compare that to air samples of ambient, subsurface, and indoor, just using basic VOC analysis. And we want to compare those things looking not only at are the same compounds present, but are there any extra compounds showing up in one versus the other? And what do those concentrations look like in comparison to one another? So one of my favorite things for CSIA Vapor Intrusion is using something called a radar plot. We borrowed this from our friends at Cox Colvin. They presented this at Battelle Bioremediation 2017, and I really liked how this visualization of the data helps out. So if we're looking at TO15 results of just VOC analysis, what we might do is start with looking at the indoor air. And we can see some of these compounds are present. We see benzene, TCE, PCE present at certain concentrations. Now we'll do an analysis of the ambient air. If we show that on our radar plot, and again, each of these kind of wheels within our radar plot is a different higher concentration, an order of magnitude higher from the previous internal wheel. So we see in our ambient air sample that it looks pretty different. We see some B-tex showing up. We don't really see much chlorinated solvents showing up, and certainly it's much lower concentration than our indoor air, which we wouldn't expect if ambient air was the actual source. So then we can compare to the subslab data. In our subslab, we notice that a lot of these have very similar contaminants, and the subslab is higher in concentration than the indoor air. So that gives us kind of a hint that this could be a vapor intrusion issue. We would expect the subslab concentrations to be higher, but have matching mole fractions as well as matching contaminants of interest. So the next thing we would do is we would turn to CSIA for an added line of evidence. So again, sample up gradient of groundwater source, sample the indoor air. Between those two samples, that gives us our two fingerprints to compare to one another. And then we're going to analyze that within the context of undegraded manufacturing range using our new CSIA database. And this is what the data came out to look like. We have our sample from our up gradient groundwater source is slightly less degraded than our indoor air sample. So again, our indoor air sample is outside the manufactured range. Automatically, that should be a red flag to us that there's not an internal source and that there's a good chance that vapor intrusion is the source. And then we can also see from this plot that the TCE at MW7 has undergone degradation between that well and the indoor air. So it may have undergone degradation through the groundwater and may have occurred through the vadose or soil pores on the way up. But it does appear, in fact, to be a vapor intrusion of TCE. So this is when we would turn to other products to try and solve those issues as well. So quickly, I always like to highlight some of the limitations of CSIA for vapor intrusion. For some clear distinctions, we need to see a lot of degradation in some cases. And this is kind of the worst case scenario. But for example, for benzene, in the worst case scenario, sometimes we need to see upwards of 90% degradation before we see a clear distinction between that manufactured range and outside that box. For PCE, even higher sometimes, again, for very specific degradation mechanisms. Another issue with CSIA is that very high volumes are required. So a lot of times we kind of have to lean back on the thermal desorption tubes. And then again, similar to any kind of issue with mixed source contributions, our isotope values can be a little confused when it comes to having multiple sources present at the same location. So kind of to recap here, sampling is very easy. Groundwater for the subsurface analysis, and then either canister or sorbent tubes for our indoor air. Now there is a way to do this, and I've gotten this question previously, to look at just carbon analysis, so one-dimensional. But as an example here, we see our indoor and our groundwater close together. Based on carbon only, we might assume that these came from the same source, that it was vapor intrusion. But if we add on that extra line of evidence, that extra dimension of the chlorine, we can see that these are pretty different. So this kind of highlights the necessity to use the dual isotope plot for fingerprinting for the best results that you can get. And it looks like I may have lost control of the slides. There it is. One other thing that I can mention is that we're starting to look into ways that we can distinguish not only indoor sources versus subsurface sources, but actually look at different indoor sources as well. So for example, we can look at different manufactured ranges for our different styles of benzene. I'm sorry that my slides keep moving around. Versus cigarettes versus gasoline, or gasoline versus natural gas. We can compare those different boxes as well. Again, always looking at the multiple lines of evidence, always using our database. As Dora mentioned, we have over 40,000 DNA samples from sites around the world, and now we have over 500 CSIA literature values as well within our database. So it adds kind of that context that you need to kind of prove what's going on to yourself and to any regulators that might be looking at that data as well. We have a number of different tools that I'm not going to talk about today, but if you have any questions specifically about biodegradation or enhanced biodegradation, please feel free to reach out to us or visit our website at microbe.com. And again, some of the tips that we offer is to treat us like a teammate. We like to be kind of the arms of whatever process you're working on. We, in turn, will help you generate actionable data, so data that will help you decide what direction to go next. Today is a good example of that, determining whether you need to spend money on some kind of way to form a barrier for that vapor intrusion versus cleaning out any type of indoor sources. And then using our database as an added context, along with trending the data we've seen, shows the best results for determining what's happening in a site. Lots of different samples that we work with now, between air, groundwater samples, any type of solids, and of course, Microbial Insights, unique tools, the biotraps as well. We can do CSIA off of any of these. We have global locations for any of you listening worldwide. We have locations in China and Canada. We have a location in Belgium and Australia. Make sure that you reach out to us if you have any interest in sampling in a different country as well. And with that, I'm going to stop on this screen and pass the mic over to Tom Szocinski. Tom works for Land Sciences. He's going to give you a little bit more of an overview of what Land Science is doing in response to vapor intrusion. Tom?
Thank you, Sam. So I'm excited to be able to be speaking here with today. We're gonna kind of wrap this up in a short time frame here, and you know, I'm going to focus on some of our new barriers that are coming out, and specifically on one of the barriers is specific to monoshield. For those on the call that are not familiar with Land Science, we're a division of REGENESIS comprised of engineers and scientists who have developed vapor intrusion mitigation solutions that protect and revitalize renewal of contaminated properties. We leverage our industry expertise to assist clients and develop site-specific solutions that are technically sound and cost-effective. And I do apologize, I'm having a bit of a technical issue here. So vapor intrusion is a driving risk. No, we need to go back. I do apologize. Go back one more, please. So Land Science, vapor intrusion, I do apologize. Vapor intrusion is a driving risk here. And so the vapor intrusion that is driving here, this is from the PVI ITRC guidance. And what we're noticing is that the industry is continuing to push and push and push and push. And the aspect of what we're dealing with is vapor intrusion is, even if you're dealing with the CSIA, we're looking at trying to identify a lot of these sites if there truly is a vapor intrusion risk. But a lot of times what we're dealing with is developments that have a certain time crunch and a certain time frame to get things done. And at Land Science, we're trying to listen to the industry, both in the construction world as well as the environmental world, and identify the right solutions for the situation. So at Land Science, as I indicated, we offer a full suite of VI technology, and in the essence of time, I'm going to get into just one specific of our new innovative barriers. We also offer design assistance if you are familiar with the Land Science. If not, we can assist from implementing vapor intrusion mitigation design to recommending specific type of barriers, and also work with subsurface analysis as well as indoor air review to complement your team as you go through your vapor intrusion assessment and process. We have a certified applicator network that is key and important. So not only do we have the VI technologies, but our certified applicators are trained by Land Science engineers and scientists to understand, to meet our specifications of how our barriers are to be installed. And last but not least is we have on-site support. So we can actually provide our scientists and engineers to be on site, to meet with regulators, to meet with your design team, and to work with the certified applicators, as well as our certified inspectors. And that's not on this slide, but the certified inspector program is another aspect that we emphasize for you to have the knowledge and training to understand how our barriers are to be installed. And so for some of the folks that are on the call right now, if you are engineers or consultants or even regulators, a lot of them can take our free training on our website for the Certified Inspector Training Program. So as I said, we do have a suite of vapor intrusion technologies. Here's 3 new vapor intrusion barriers that we have recently released in 2019, TerraShield, NitroSeal, and MonoShield. And for the essence of time on this one, I'm going to emphasize on the last one, the MonoShield, and I'm going to spend a little bit of time talking to you about that today. So MonoShield it's a rapidly installed reinforcement aluminum barrier nitrile asphalt sprayed sealed seams, and that's actually a ghosted picture in the background, and we're going to go to in a little more detail so it gives you a little more understanding of kind of what our MonoShield is. So MonoShield specifically was designed for brownfield sites where vapor intrusion mitigation may not be required due to a lack of regulatory requirements, but the developer still wants to ensure that he's reducing liability, creating a better increased protection at a competitive price as well. So there's been a proven market and need for this preemptive vapor intrusion mitigation at what some might characterize it as a low-risk site. This market has been traditionally served by a thin mill type plastic sheet that's designed more often for moisture and water vapor barrier protection, not for contaminant vapor barrier. These systems, they're not chemically resistant and are constructed with tape seams often, and the tape seam penetrations are highly susceptible to contaminant leaks and or damage from underslab conditions. So MonoShield provides a simple to install and chemically resistant barrier that's competitive with the thin mill plastic systems. Unlike the thin mill, MonoShield provides protection against the contaminants that we were just talking about, PC, TC, benzene. And in addition, MonoShield it's much simpler to install and faster to install in compared to the traditional alternatives. So here's a quick diagram of kind of what you're looking at. That is actually one sheet good, but it is all thermally bonded together. So MonoShield provides a significant improvement over both the thin mill plastic sheets and the HDP bonded welded systems that are inflexible sheet goods. The MonoShield incorporates superior chemical resistance with the constructability of a spray-applied nitrile asphalt latex. These seams and penetrations are tightly sealed and verified by smoke test, which is a key QA/QC process to ensure the competence of this vapor barrier. In addition, as I said, the ease of application is significant over a tape system and the heat welded HDPE systems. And unlike the thin mill systems, MonoShield provides an unparalleled design support backed by our land science technical sales team and engineers. And we also offer warranties, which I will get into in the coming slides. So really important here, though, is the chemical resistance. So internal testing, specialized testing that using this chamber here on the right side of the diagram that you can see. And the results were identifying that the mono base, which is the base of the MonoShield, is 10 times more chemically resistant than HDPE. Great to have internal testing, but even more important to have the independent third-party testing. And as you can see here, published is the MonoShield benzene diffusion coefficient of 10 to the minus 15. So for those of you that diffusion numbers are great to see on paper, you can take these numbers and implement them into a modeling program to identify what your site-specific attenuation factor would be if you utilize MonoShield. So one of the other aspects of MonoShield that I want to get into, it's a highly chemically resistant barrier, the mono base, because of the aluminized metallized film that is infused into the barrier. But then we also implemented a new barrier, or new spray apply nitrile modified asphalt core called NitroCore. It's got no VOCs. It actually has a higher tensile strength than our previous latex asphalt, and it significantly improves chemical resistance. As you can see here, the NitroCore provides up to a 10 times more chemical resistance than the standard styrene butadiene based core that has been previously used on the latex sprayed asphalts. So as I mentioned, you can see here, these are pictures of the seams being sprayed. They're sprayed at a 6-inch overlap and a 30 mil spray and then a 60 mil cap over the top of that, creating that seamless effect. But as you can see here, it's still just a single layer system. Complementing that, we can also our TerraVent. It's a low-profile venting system that reduces that install cost. So before the MonoShield is installed, you can install this Vapor Vent and TerraVent, and the venting system itself will provide that solution of a preferential pathway for the vapors, but it also can be used in active venting system as well. We encourage that you work with the land science team as you're deciding to design a TerraVent system, and we'd be glad to provide our slew of details that we have already previously provided of non-site specific, or we can work with you on site specific layout systems as well. As I mentioned, the QA/QC is utmost importance to us. I brought up the certified applicator network, the inspector training, the certification. Part of that QA/QC process is not just these trainings, it's also smoke testing, the field QA/QC. So you can see here in the picture the gentleman actually pumping smoke into the system. It's important because you're identifying the potential leaks and then repairing them with a visual inspection. And this is just a quick to say that our certified QA/QC program is not just on the product that I'm talking about today for MonoShield. It's for each one of our suite of vapor intrusion solutions. So TerraShield, NitroSeal, GeoSeal, MonoShield, and RetroCo. And as I promised, we wanted to briefly share with you the warranties that we offer for MonoShield, a 1 and a 5-year material warranty. And so what we encourage is that if you have a site that you're considering MonoShield as a preemptive site, work with our team and we will identify the best barrier for your situation. MonoShield could be the absolute solution for it. It has been designed originally, like I said, for a preemptive approach for warehouse type developments, but that's not to say that that's the only slot that would fit into. So we do encourage, if you are interested in the MonoShield after this webinar, if you have questions or comments that we maybe even not get to today, that you get in touch with us, our team, and we'll be glad to work with you. And lastly, what I want to do is just walk you through a successful case study already with MonoShield, and yes, that is already happening. So the building Ghosted in the background is the Liberty Park site in southeast Michigan, and this is a 600,000 square foot facility that is located in Sterling Heights, Michigan. It's 23 miles north of downtown Detroit. If you're not familiar with southeast Michigan, Detroit obviously is Metro Detroit for many reasons of the concepts that you have Motor City. Well, it spread out into the urban sprawl many years ago into the Sterling Heights area. So in the last 5 years, though, however, this region in Sterling Heights specifically, it's experienced a growing demand of warehouse, and the area is perfect for transportation of in and out. So this site, unfortunately, was a landfill-based brownfield site that was historically contaminated from the 40s and 50s. So Liberty Park, it posed a multiple remediation challenge that included the site settlement conditions, and because of the site settlement conditions, the load-bearing issues, they had to have a unique type of foundation, which also required a unique type of vapor intrusion mitigation solution. So here's a quick timeline. As you can see, incinerator waste was placed at the site, leading to the contaminated conditions. They then implemented a redevelopment of it to Liberty Park Recreation Complex, and then it ultimately was closed, and Liberty Park was closed in 2017, but Ashley Capital, LLC, purchased it for redevelopment. In June of 2018, working with SME, as well as Oliver Hatcher, they decided to move forward with the construction, and SME had brought in Land Science to bring in the innovative new barrier MonoShield, and in May of 2019, MonoShield was installed. So the highlights here, it's a competitive tax increment finance plan for the state of Michigan, the city of Sterling Heights. The state of Michigan and the city of Sterling Heights were actively involved in this brownfield redevelopment. So they were right into the details of looking at information related to this MonoShield vapor barrier, and we were excited to be able to gain the approval not only of from the city, but also more importantly from the state regulating community. Liberty Park is being transformed into a property that is going to bring significant amount of jobs and growth to the community. And the MonoShield merges the benefits of the both rollout barrier and the spray applied. So like I said, a unique situation on this site. And so here's just a quick picture of the inside of the building. You can see this is a comment from senior consultant Mark Quimby. I'm not going to read verbatim, but you can read it yourself. But looking inside the facility, it's a wide open area. Perfect opportunity for bringing in a preemptive type mitigation barrier like MonoShield. This is a quick quote from Ashley Capital, and if you haven't been to our website recently, I encourage you to come to our website. We do actually have a case study video on this site as well. But as you can see here, the MonoShield system was the most cost-effective system in the market, and this is right from Alan, that we've been able to shave off a couple months of our construction by going with the system. Now, that's not to be confused to understand that the shaving off the couple months wasn't just because of the MonoShield system. It was an implementing concept of using the MonoShield system that expedited the concrete process and everything else. And then one more quick case study, and then I'm going to wrap it up, is the Hazel Park brownfield. And this is excitingly going on at the almost exact same time as the Liberty Park. You see a horse ghost in the background? Well, it's not, that is because it was a former horse racetrack. And it's also in the southeast Michigan. And this also was another 600,000 square foot facility. So in the 40s, it was a former landfill and incinerator, similar story. So this one, instead of going to a recreation facility, became a horse racetrack and opened in the 1949. But due to demographic and financial changes, the park was officially closed in 2018. 2015, the portion of it was developed as a first Tri-County Commerce Center. And in 2018, Ashley Capital purchased the rest of the Raceway Park property to develop the Tri-County Commerce Center 2. This is a quick timeline. 1949, as I mentioned, it was the Hazel Park Raceway opened. 2015 was the commencement of the first building. 2017, we're looking at the continued development, and you see here similar names, Oliver Hatcher and SME. Land Science works closely with SME on this site as well. And in June of 2019, monoshield was installed for the Commerce Center building number 2. An anticipated completion date is this fall of 2019. So brief highlights here is several organizations, including the City of Hazel Park and the State of Michigan again, working through the approval process, not only construction, but the environmental. Tax incentive for the state was key for the Brownfield Redevelopment Act. Monoshield was chosen yet again for this one based on the successful application of the nearby Liberty Park, as I just gave to you. And the project was assured of staying on time and on budget due to the reliability of the cost effectiveness of monoshield. And lastly is the results of both. Liberty Park and Tri-County Commerce Building had preemptively protected from vapor intrusion. It's completed in late summer and in the fall of 2019, and it's bringing significant job growth and economic growth to Eastern Michigan. All the stakeholders are pleased with the results, and as I said, I encourage you to go to our website to watch the case study videos and read the case studies. And with that, I'm going to turn it back to Dane for some questions.
All right, thank you, Tom. That does conclude the formal section of our presentation. Have time for probably just a couple of questions here. Before we do this, just want to remind you, you're going to receive a follow-up email with a brief survey. So we really appreciate your feedback. So please do take some time to let us know how we did. And we're also going to send this a recording of this webinar as soon as it's available. All right, so we have a question here. This is for Microbial Insights, and the question is, can CSIA also prove degradation in subsurface soil vapor samples?
Yeah, soil vapor samples can certainly be sampled and analyzed kind of in the same way as indoor air samples. There have been some mixed results with sub-slab soil vapor samples, but that's recorded in that same document that I showed earlier. But in general, yes, we can definitely look at soil vapor. And the main reason we say groundwater is simply because it's less expensive of a comparison and still a good comparison.
Okay, all right. So next question here. This is another question for Microbial Insights, and it is, how does your lab determine which compound is conducting the isotope analysis on? And this person goes on to elaborate that most sites have dozens of different compounds. So is there some step to separate the compounds before your analysis?
Yeah, so with Compound Specific Isotope Analysis, pretty much any CSIA analysis that's industrial right now is using gas chromatography on the front end. So that's why we're looking at volatiles, of course, here, because otherwise we wouldn't be talking about vapor intrusion. So we're using GC analysis on the front end to separate those compounds through those columns. So yes, that's how we can differentiate which compounds we're looking at.
Okay, great. So time for a couple more questions maybe here. This is a question for Tom. And the question is regarding monoshield. The person asks, why is the monoshield constructed with an aluminum layer? Does it shield against vapor intrusion of certain types of VOCs? Why the aluminum layer?
So that's a good question. We worked with our research development team to identify a more chemically resistant barrier, and the metallized film creates that opportunity for us. So infusing the metallized film, aluminum film, into our monoshield, as well as, and I didn't get into it, but our TerraShield has a dual aluminum metallized layer. It increases that chemical resistance in orders of magnitude, and with series of tests it identified that this was the best opportunity of creating an even more chemically resistant barrier.
All right, great, thank you, Tom. So maybe time for one more question here. This is another question for Microbial Insights, and it is, have you had success having these analyses accepted by the regulatory agencies?
Yeah, so one thing that I failed to mention in this talk is that CSIA has been around for a long time. It's kind of been introduced in the EPA. They released their guidance document for CSIA for groundwater in 2008. Even within the environmental remediation industry, it's a very well accepted and understood science. There's plenty of research looking into lots of different conditions of analyzing different types of samples. So yes, we have definitely had good success with CSIA, all around, in fact.
Okay, great. Thank you so much, Sam, and also thanks to Dora, and thank you, Tom. That's going to be the end of our chat questions. We had a lot of questions today, so if we didn't get to your question, we're going to make an effort to follow up with you. If you want to learn more about molecular biological tools from Microbial Insights, please visit microbe.com. And if you'd like to learn more about vapor intrusion solutions from Land Science, please visit landsciencetech.com. Thanks again very much to Dora Taggart, to Dr. Sam Rosolina, and to Tom Szocinski. And thanks to everyone who could join us today. Have a great day.